Hi everyone, my name is Valentin Hamburger. I'm doing a session for vBrownbag on Cisco Live 2016 and I'm excited for the topic, which is called the Programmable Datacenter. And let's have a look what it is. So we had a mission and a mission statement for a customer where we actually were required to provision a multi-layered application, which means that we need to provision a virtual part and a physical part of that application based on a requirement the customer had. In our case, they wanted to have one platform where they can do everything together. They don't want to have a separated platform. They wanted to have an end-to-end automation so that it's an easy consumable service, just clickable and it works. They wanted to have an X as a service, like anything as a service capability environment. Maximum flexibility and reliable and reusable workflows to actually provide a good result. So what was the idea? What was the customer actually required? So in this example, we did a POC and we created it using an example application which is called Sugar CRM, which consists out of a database part and an application part. It's the most known-able application for this POCs because it's free of charge. So we just used it to play around with it a little. What we did is we made a service which is in a portal. In our case, it was vRealize Automation. If the customer clicks or if the administrator clicks on the service, it deploys a VM and a physical blade containing the database, a VM containing the application, all together as one single application in one data center. So you have an automation across physical and virtual assets with one click. And that was the mission statement, that was the idea what we wanted to produce. So what were the layers we used? So we used vRealize Automation, obviously, because it was a given. Also, vRealize Application Services, which comes with vRealize Automation. In the middle, we had vRealize Orchestrator to actually run our workflows, to do our workflow management and orchestrate all the tasks across the infrastructure. We used Puppet. Puppet was the obvious choice to do actually the application deployment on the physical part. And it was the easiest thing to control in this environment. Also, we used the Unified Compute Platform from HDS, which was the converged platform the customer chose to actually run their workflows, luckily. And VMware vCenter and vSphere Hypervisor as the virtualization platform of choice. And together, we chained all these layers, all these tools together to run as one unified engine to actually provide the service and to act as the endpoint for your service delivery without any third-party handovers or so. So what was the challenges? So there were a couple of challenges. For instance, vRealize Application Services does not provide any endpoints as a physical. So you cannot do application deployment on a physical blade or on physical Windows. Also, bringing all together in vRealize Automation was quite tricky and have a one tile to click, like a one service to consume for the customer. Also, what we wanted to do, what the requirement was, it needs to be customizable. So there needs to be a custom DB name, a custom application, a username to actually have the deployment customized to the customer needs. And of course, bringing all the APIs seamlessly together without any interference, so that it always works. So it's not a service which should sometimes work. It always works, and it's always the same experience for the user. That was the critical point in this whole undertaking. The man in the middle was indeed the vRealize Orchestrator, and it was the part where we spent most of our time actually making everything happen and making everything work together. We were able to actually, and that's a good thing, we were able to leverage an API preset of calls to do the bare metal deployment. So we didn't have to tinker around with how to set up a bare metal Pixie boot, whatever, because that was a part of the converged platform. So we let the converged platform do this stuff for us. All we did is created a workflow and told the workflow, use this kind of disk, use Windows, put this on top of it, and then go for it. That was a good thing. The tricky part was then control the Puppet master and make Puppet work together with this. But again, after a short period of tinkering around with Puppet, it was quite clear how to do that. So what we needed to do is we put the Puppet agent in the base OS of Windows on the bare metal blade, deployed it. After it's deployed, it will itself register to the Puppet master, and all we have to do is signing the registration, and there we go. And then we can put the manifest on the physical blade to make sure that the database is installed, and in the manifest, in the module, we define how the SQL database server is actually set up, and there we can also set the user setable variables like username, DB name, password, and so on. So that was all done using vRealize Orchestrator to control actually the Puppet master. So the deployment process looked somewhat like this. So there's a service request, physical deployment comes first, of course. Once this is done, we push the database on top of the physical resource and configure it. Once this is done, we go back to the virtual machine deployment, which is done by vRealize Application Services with native functionality. Then we push the application server deployment on top of that, which is the application server part of Sugar CRM. And then the service request is finished, hopefully, successfully. How did we do it in vRealize automation then? So we had the virtual Windows blueprint defined, of course. We linked it together with vRealize automation. There is a couple of good blocks how to do that if you have never done this before. It's quite straightforward. Application services were linked together with the VRA blueprint. And then we created external services in application services. So before we actually provision a virtual machine, we had to have an external service which calls the vRo workflows. Okay, so for this, I had to create actually a small Java binary, which is relying to the REST API of Orchestrator to do that. And then we had two calls, one for deployment of the blade server, one for the deployment of, one for the signing request of the Puppet master to make sure that works. And then we were going on with the rest of the deployment in vRealize automation for application services. The preparation we had to do in the platform was we need to make the blade service template, as it is called in UCP, deploy-able with Windows 2012. And we put a Puppet agent on top of that OS so that it comes with the deployment of the physical Windows, it comes the Puppet agent. Also, on the Puppet master, we had to create a Microsoft SQL module, which is actually containing the software and the configuration and the manifest data, and make it customizable. Also, we created the manifest for the system, which is then ready to be pushed once the system registers itself to the Puppet master. And this can be and should be controlled via the vRo service to make it customizable and reusable for other tasks. Also, we have some lessons learned here. So Puppet is very version critical. So once your agent is more advanced than your server, the agent will never register itself to the Puppet master. That's very critical. Also, workflows need to have good and proper return codes. That's super critical in every project when you do workflows. So just don't put just a silly wait statement in there. You need to have a response from a workflow saying, I was successful, this is done, and you need to wait until it is successful. If we do the deployment of the server too fast and the database is not deployed, it will fail. The other way around is also not good. If you have a database but there is no application service deployed, you also have no service. So make sure that you have good and proper return codes. That's key in every project. And make speakable error codes, not just error 405 happened. Nobody knows what 405 is. So also, I already told you that I needed to create a little Java app, and this is quite odd because application services in 6.2 has no way controlling vRealize Orchestrator. So I had to put that in myself to actually make the REST API controllable from vRealize Orchestrator from application services. Okay, so what have we done here? So we created one service containing physical and virtual assets and deployed this. It was an extent of the native vRealize automation application services by actually adding physical deployment with ease and with the use of Puppet. We combined all layers together as a uniform deployment mechanism, as I said before. We had a transparent and easy outcome for the requester and no need for handovers. So it was all one deployment. So there is no physical service department you need to call and say, by the way, I need a Windows system. So this is all done for you automatically. And we try to web everything together and have a virtual and physical tasks in the data center, which is then truly the programmable data center, where you can call it as, if you even want, so the software-defined data center, including physical assets. And with that, thank you very much. If you have more questions how this all worked, and if you want to see the, let's say, behind the curtains, we will do a series of blog posts on community.hds.com containing all the material, containing all the configuration and the workflows. So please check that out. Thank you very much.